In this lesson, we're going to take a look at sections 4.4 and 4.5. There's not much in 4.5 that isn't a review of what you learned in sections 4.2 through 4.4. Now, I have a couple of problems that I just want to review with you in 4.5, but we're going to start off with 4.4, which is special case. And in special case, these are things that when you look at them, you recognize them as special case for factoring. Let's take a look at something that we did earlier when we did the FOIL system, where we multiplied x plus 6 times x minus 6. And what we got was x squared plus 6x minus 6x minus 36. These two right here in the middle, the plus 6x and the minus 6x, then canceled themselves out. And what we ended up with then was x squared, oops, my fault. Let me erase that. Put that in black. X squared minus 36. This is our first special case. What we note about this is the first term is a perfect square, x squared. And the last term is a perfect square, 36 being a perfect square because it's 6 times 6. And the sign in between the two is negative. If that was x squared plus 36, you couldn't use this approach to factoring that. In fact, you'd be done. But if you'll notice that if you have a perfect square minus a perfect square, then the pattern is the square root of the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. And you can do it in either order. In fact, in the book, what they like to do is first term plus, not first, and then first term minus. But let's take a look at number 12. Square root of square root of r squared is r. Square root of 9 is 3. So what we get is r plus 3 times r minus 3. It's just that simple. Look at number 16. Now the first term happens to be a number, 81, but the square root of 81 is 9. So what I get is 9 plus the square root of the second term is b, and now I just write the same thing, only put 9 minus b. It's that simple. So when you see this combination of two perfect squares separated by a minus sign, you'll know that you've got a special case. In number 20, the square root of 4 is 2. Square root of x squared is x. So you have 2x, and then the square root of 25 happens to be 5. So 2x plus 5, and then 2x minus 5. In number 24, they made it a little more complicated, but it's not hard. You'll notice that 25 is a perfect square and 81 is a perfect square, and then you have an x squared and a y squared. So the square root of the first term happens to be 5x. Square root of the second term happens to be 9y. Once you figured out the first one, then it's the same thing, 5x only minus 9y. In number 40, you don't have that. It looks like they're trying to trick you, but you do have two common factors that you can factor out of that. First is 2, because 2 will divide evenly into both 50 and 2. And the second is b. When I pull those two out, what I end up with is 25a squared minus b squared. Now I have a perfect square for the first term and a perfect square for the second. So when I rewrite that as 2b times 5a plus b times 5a minus b. And there we go. All right, so that's when you have a perfect square minus a perfect square. The second special case is, if you recall, when we multiplied two binomials that were exactly the same, such as x minus 6 times x minus 6. We got x squared minus 6x minus 6x plus 36. And when we combine those two middle terms, we got x squared minus 12x plus 36. Now this is special case because if you look and you have a perfect square in the first term, and the last term not only has to be a perfect square, but it has to be plus. If it's minus, this is not a special case. The middle term can be either positive or negative, and I'll show you examples of each. But if we take a square root of the first term, in this particular case x, and then we take the square root of the second or the third term, which is 6, we get 6x. If we double that 6x and we get the middle term 12, we're golden. The only thing that tells us whether we're going to be making that x minus 6 or x plus 6 times itself is whether the middle term is positive or negative. All right, let's take a look at a couple of examples. Number 70. X squared is a perfect square, 9 is a perfect square, and that middle term happens to be positive. All right, that being the case, when we take here the square root of the first term, it's x, and because that middle term is plus, we put in a plus 3, and that turns out to be times x plus 3. Now, one other way you could write that is the quantity x plus 3 squared. I don't know that that's what they do in the book. Yes, I guess it is. So now let's take a look at number 72. In this particular case, that middle term happens to be negative. With that being negative, now square root of the first term happens to be x. Square root of the third term is 4. Only this time, instead of being a plus 4, it's a negative 4. Because if I take negative 4 times negative 4, I'll get a positive 16. But because my middle term is negative, now it's x minus 4 times x minus 4. Or in the book, they would put x minus 4, that quantity squared. Looking at one that's a little more complex, notice first term is a perfect square because 4 times 4 is 16, x times x is x squared. And the last term, 25 is a perfect square, it's 5. Why? Well, if we took 4x times 5y, 4 times 5 is 20, x times y is 20xy, and we doubled it, we would end up with 40. So there we have that perfect square. So what we have is 4x plus 5y times 4x plus 5y, or as they put it in the book, 4x plus 5y, the quantity squared. So there are the special cases that you'll find in the book. What I want to do now is I want to erase what we've got on here, and I want to look at a couple of special cases in section 4.5. Much of 4.5 is a review of what you've had, and so that's the reason I've made that assignment at 4.5. And there is material there that you can look at in that chapter to help you with your review. And I want to take a look at a couple of things we won't deal with very often, but you may want to know how to figure them out. The first one happens to be problem number 46. Now, problem number 46 says y cubed minus 64. And you want to figure out what are the factors for that. Well, first of all, you have to have a perfect cube root for both terms. And the perfect cube root for y cubed happens to be just y. The perfect cube root for negative 64 happens to be negative 4, because negative 4 times negative 4 gives me a positive 16, but a positive 16 times a negative 4 gives me a negative 64. So the perfect cube root for that happens to be negative 4. Now what I want to do to get the rest of the factors, I want to divide that into y cubed minus 64. So our first term, y into y cubed, what I get is y squared. And when I multiply that across, y squared times negative 4 gives me negative 4y squared. And y squared times y gives me y cubed. Now when I go ahead to subtract that, I'll have to change this to a negative, that to a positive, and this becomes now 4y squared. So when we did that division a while back involving binomials, I guess there was a purpose in that, although we're not going to do many problems like this. Now I don't have anything to bring down, so I ask myself, how many times will y divide into 4y squared? And it will divide in a positive 4y. Now when I take 4y times negative 4, I get negative 16y. And 4y times y gives me 4y squared. But then when I go to subtract that, this becomes negative, that becomes positive, and now I have 16y. And now I bring down my negative 64. How many times will y divide into 16y? Well, it'll divide in 16 times. 16 times negative 4 gives me a negative 64. And 16 times y gives me 16y. Now, when I go to subtract that, this becomes negative, that becomes positive. We have 0. And there you have your factors, which are y minus 4 times the quantity y squared plus 4y plus 16. You can look at that second trinomial and ask yourself, can we factor that some more? We've got a perfect square in the first and a perfect square in the third term, and then so y times 4 is 4y, but if I double that I get 8y. That's not my middle term, so we're done with that one. All right? Now what we have is one more problem, and you have to flip the page because this one is on page number 278. In fact, it happens to be problem number 78 on page 278. So what we're going to do is take a look at that problem, and that's the last of the problems we'll look at. We want to know what are the factors for x cubed, oops, my fault, x cubed minus 2x squared minus 9x minus 18. Well, this is pretty complicated, and we don't really know where to begin. Can we factor out a common factor? No, we don't have a common factor we can pull out of that. Since there's 4 terms here, what I'm going to do is that factoring by regrouping, by splitting this into 2 parts. Now, what can I pull out of that first part? Well, I have an x cubed and a 2x squared. The common factor there is x squared. And what do I have left? I have x minus 2. How about the second one? Well, what I've got there is negative 9x, negative 18. I think I can pull out a negative 9. And what I end up with is x minus, or x plus 2. Oh, I copied that incorrectly. That's why. My fault. I was a little confused there. It helps if you copy the problem correctly. So, now when I pull out a negative 9, what I get is x minus 2. My apologies. We'll go on. Because we have a common factor now, it's x minus 2. And what I have left is x squared minus 9. Now, that x squared minus 9 is a perfect square minus a perfect square, so that can be factored. And we have x minus 2 times x plus 3 times x minus 3. So, and I do apologize for not copying that correctly, but that is the problem number 78 on page 278. And there's an interesting solution to that.